So I'm very happy to introduce to you the speaker of our next talk, who is Andy. Andy has made himself a name in social media, mainly in TikTok, but however, not in the way that most people do, but actually he provides some really interesting and relevant content. We all know, even maybe it's not true for the majority of the attendants of the big tech day, and especially in this room, that for many, many people around the world, mathematics is not the favorite subject. And Andy tries to help these people by explaining mathematical concepts and providing solutions to mathematical issues and riddles in very short and descriptive and understandable videos on TikTok. I don't want to spend too many more words on him because he's the one who can talk more interestingly about his work. But one more thing, for those who are here remotely, we will have time for your questions after the talk for 10 to 15 minutes. So if you have any, feel free to ask them in the Slack channel, and then we can ask them to Andy afterwards. Okay, with that, I will hand over to Andy and wish us all a very interesting talk.
That's crazy. Wow, I was not expecting a full room. This is exciting. So yeah, I'm curious, how many people here have seen my TikTok? Very minimal, okay. But yeah, so just my quick background. I used to be an actuary for a couple years, so I had a lot of math done with that. And then I worked in edtech for most of my career. So did a lot of digital advertising. So if you guys got served ads online, sorry about that. Probably I played a small part in that. And then now I'm a math tutor full-time, and I make the TikTok videos, and then I have a website, andymath.com. So just thought we'd start with a fun one. This is a video I did probably about 2 weeks ago, and I'm literally just going to show you guys the video. This is kind of like when you're at school and you just get to watch a video. Let's see if this works.
We fold a piece of paper 42 times. It's thick enough to reach the moon.
You want to see the math? First, what is the distance to the moon? If we Google it, it is 384.4 million meters. Put a box around it. Next, we got to find the thickness of a piece of paper with 42 folds. First off, what is the thickness of a single piece of paper? If we Google that, it says 0.05 to 0.1 millimeters. So it's somewhere in this range. This is given to us with the precision of 4 significant figures. So let's do 4 significant figures. I will go with 0.0874 millimeters. Now let's look at one fold. We would take the thickness of our piece of paper, multiply it by 2 to the 1, and we would get 0.1748 millimeters. Or if we did 2 folds, we would multiply it by 2 squared, which would be 4, and that would give us 0.3496 millimeters. And 3 folds would be equal to this multiplied by 2 to the 3rd power, which is equal to 8, and that gives us 0.6992 millimeters. Now if we had 42 folds, that'd be multiplied by 2 to the 42nd power. It's this very large number right here. After we multiply these, we get this other very large number. This multiplication has introduced extra precision that does not exist, so I'm going to cut it at 4 figures, so this 3 will round up to a 4, and the rest of this stuff is just going to be zeros. So now we have 384,400,000,000 millimeters. So let's copy that down, and this was in meters, so let's convert this to meters. There's 1 meter for every 1,000 millimeters. When we multiply these, the millimeters cancel each other out, and we divide top and bottom by 1,000, which just gets rid of 3 zeros for both. Let's bring down the rest of this number, and let's bring down meters. This is 384,400,000 meters, or in other words, 384.4 million meters. Let's give it a label. This represents a paper with 42 folds, and let's put a box around it. Let's bring this box up here, and let's compare these. The distance to the moon is 384.4 million meters, and a piece of paper with 42 folds is 384.4 million meters. The math checks out. How exciting. Oh, because of the camera. Because of the camera. Okay, cool. Yeah, thanks. That makes sense. Yeah, thanks. Yeah, so as you can tell, like I rigged it so they'd match perfectly. It was kind of part of the joke where I chose paper that would work. And another thing that people comment on, like little stuff like this, a lot of people already know, but I try to do a wide range of material so that even if a middle schooler was watching this from America, they could still convert it. So it might seem silly to a lot of European adults watching it, but I try to do a full range. So even if they don't understand everything, somebody can get something out of the video, is kind of what I was going with that. And obviously it's a silly topic, but it's getting people excited. And in fact, so this is the original. These are the guys that started it. They got about 9 million views. And then mine, doing the math, got 17 million views, which just amazed me. 17 million people chose to watch that instead of flipping through and watching people dancing or doing something fun. So I think they're enjoying seeing the math.
even more so than the guys who originally did it. So that was kind of fun. And in fact, that's 17.4 million now. I did that. I updated it last night, so it's still kind of growing, which is kind of fun. These are basically the two types of comments I got. So many, 142,000 people like this. Like, it's so funny the number of people who feel the need to, it's obvious it's a joke, but people, I guess, are helping out, letting people know it's not actually going to work. But this is the one I really like. Can we see how insanely narrow the moon bridge paper would be? I answered this one. I did a follow-up video. It's like 3 minutes long. I don't know if we actually want to watch it, but it's kind of interesting how if you chop it up and you compare it to like a piece of, actually, maybe I should watch it. It's all right. It's a fishing line. If you take a fishing line, you cut up in like 400 slices. That's about the width it would have been. It ends up being something like 1,700 atoms. It would be a cross-section slice. So it's pretty small, obviously, but it was kind of fun.
Hold a piece of paper.
Oops. And then here's the discussion people went over. Oh yeah, so people were doing the math. They were like figuring out how much stuff would be, and people were getting really involved in solving it. Yeah, but I think someone figured out it's like 1,700. Yeah, doesn't matter. And then, okay, this is my highlight right now. So man makes me enjoy math. That's my whole goal. So more so than teaching, there's already so many people teaching online. I just want to make this enjoyable, make it fun. And I think with that fun, people will get a lot more out of it and grow from there. So intro to TikTok. I'm sure most of you know TikTok is an entertainment app. It's pretty straightforward. And a lot of people I think here might like the data and algorithm. It's amazing what they can do with these 6 data points. So it's just watch time, likes, comments, follow, favorite, share. I don't think there's anything else that they can track. So this whole successful TikTok is based on how well they wrote the algorithm to input these 6 things. But what I think is super important is that it's full attention. So someone who's on it, they are required to swipe. So it's not like YouTube or watching TV where you can just sit back and watch a playlist. You have to keep swiping. If you don't, it's just going to keep looping. And you're going to keep seeing the same thing over and over again. So someone has to stare at that screen. So if I'm making a video, someone's got to look at me through the whole thing, which is kind of cool. And then it's safe space. So usually if you're on TikTok, you're at home on the couch or something, you're not distracted by other things. You're just giving full attention, which I think is incredible for education. And then also the loops is kind of fun because if someone didn't get something the first time, just watch it again and just see what's going on with the part you missed and watch it. So it's kind of a neat feature. Plus, like I said, that requires the swiping as well. I made this visual for safe space. Really just most places you learn in school, you have all these other distractions, whereas on TikTok, you can just learn the math. You don't have to worry about things too much. Oh yeah, I had some funny ones thrown in there. I didn't know the screen was going to be so big. I didn't realize people could actually read the things I wrote. But okay, so this is my first viral video. I was posting videos, it might have been my 30th video. And I was pretty lucky early on, like I was getting in the thousands right away. But then there's these, and then along came the 671,000. It was a pretty crazy morning. I remember waking up and just seeing all these, because I usually upload them before I go to bed. But, oh, here it is. Do you guys want to see this one?
You may have seen this bar before. What it means is that 9 is going to go on forever. This means the same thing as 1. How is this possible? There is a neat way to demonstrate it. We'll say x equals 0.9 bar. So I'm going to rewrite this showing some of the 9s that follow. They go on forever. Multiply both sides by 10. X by 10, that's 10x. If you do 0.9999 times 10, moves your decimal place over 1 spot. 9.99999. I'm going to rewrite that up here. We have our original x that we assigned, and we multiplied it by 10. I can subtract these 10x minus x, 9x's. All of these 9s going on forever are going to cancel each other out when I subtract. 9 minus 0 is 9. Divide both sides by 9, and we get x equals 1. If you remember earlier, I said x equals 0.9 bar. We must conclude that 0.9 bar equals 1. This is just a fun demonstration I wanted to share with you. I hope you liked it.
So I just like these other videos I had back here, I didn't think it was anything special. It was just something I was just making, goofing off, and posting, and then it just blew up. And I ended up being so popular that I made a whole bunch of other videos on the same topic, lots of different videos. But I think, let's see, what do people say? I love all your variations, proving that it's great. Yeah, so people love the variations. Respect your dedications, yeah, because I've been doing it for quite a while. And then, this is fun, yeah, no matter how many times you do the proofs for this, I will appreciate it every time. So it's kind of fun that people are watching and enjoying it. I appreciate their appreciation. Here's like a quick one. I don't know if everybody already knows this or not. I actually have not made a video using this demonstration because I think it's pretty simple, but just 1 divided by 3 is 0.33333, and then 3 times both sides, you get 1 equals 0.9 repeating. It's kind of a fun thing. Here's another reason I think it was very popular. On iPhones, they cut off the bar. It was not intentional. I did not know this. In fact, I didn't have an iPhone when I uploaded this a year and a half ago. And it's, so a lot of people in the comments were like, 0.9 doesn't equal 1, this is ridiculous. And it was, so I think that might have been another reason why it blew up, was just the controversy there. Oh yeah, and I zoomed in to show it. But like I said, I didn't know it was gonna be so big. So the second viral video, so same thing. The next one got 1.7 million immediately after this. And really, I concluded it was the discussions in the comments that made that one get so big. So immediately actually the same day, I Googled what's the most controversial math. I wanted to know what it was. And then I found this guy had this video 0 to 0. So then I didn't know what it was. I had to Google what is 0 to 0. And it said 1. I was like, wow, that's cool. I had no idea. So I had no idea what I was doing. I'm not kidding. And I made this video. Just made it up on the spot, no idea.
0 to the 0. 0 to the 0 equals 1. Wait, what? So 0 to the 2 is 0. 0 to the 1 is 0. 0 to the 3 is 0. 0 to the 0 is 1. Why is it 1? Let me try to explain how I think of this. 60 is 2 times 2 times 3 times 5. Now we can express this 60 as 2 squared times 3 to the 1 times 5 to the 1. This 2 right here says we have 2 2's. This 1 right here says we have 1 3, and this 1 right here says we have 1 5. How many 7's do I have? 0 7's. 0 11's. This 2 squared is really 4, and this 3 to the 1 is a 3, and this 5 to the 1 is a 5. This 7 to the 0 is a 1. It would have to be 1, because if it was anything other than 1, it would no longer be 60. As I'm looking up here, how many zeros do I have? I have 0 zeros. This also has to be 1. And that is how I think of 0 to the 0 and why it's 1, is because it means I have 0 zeros.
So yeah, so I did not know this. I literally just made this up. I had no idea if it was true. My count was tiny at this point, so it really didn't matter if I screwed up. And I just did it, and it ended up, oh yeah, I made this up. It ended up being a real concept. This is a real thing. It's called the empty product. I rediscovered something that someone probably discovered a long time ago and made this video. But people were so upset. There's so many people who say, no, it's undefined, it's not a thing, and 0 to 0 equals 1. And kind of the arguments, both sides are kind of right. I won't go into detail, but one side's really talking about just the arithmetic expression, and then the other side's talking about limits. And kind of the limits thing is, if you take something like x to the 0, as it approaches 0, it's going to equal 1. So like 3 to the 0, 2 to the 0, 1 to the 0. Whereas 0 to the x is 0, so since they're different, they just say that it's undefined, but controversial. So then obviously I made a whole bunch of videos on it, and they did pretty good. But my favorite one, this is probably my favorite video I've ever done, is this one right here. So I'll play it. I have a special visiting guest in this one. You seem like a pretty cool dude. Do you want to talk about 0 to the 0 and why it equals 1? No, 0 to the 0 is undefined, man. See, it goes like this. 0 to the 0 is equal to 0 to the 1 minus 1, which is equal to 0 to the 1 times 0 to the negative 1, which is equal to 0 over 0. And division by 0 is undefined. Therefore, 0 to 0 is undefined. Okay, I like that. That was a fun demonstration. I knew right away you were a cool dude. Now I have a follow-up question for you. If we have 0 squared, that would be equal to 0 to the 3 minus 1, which would be equal to 0 to the 3 times 0 to the negative 1, which would then be equal to 0 cubed over 0. But I see division by 0, and we know division by 0 is undefined. So does that mean 0 squared is undefined? That's a really clever argument, but that is not correct, because these zeros would cancel, and this would give you 0 squared over 1. Because you could cancel 1 0 from top and bottom. And that makes your statement here incorrect. So let's get rid of it. Okay, that was a good argument. I see how you did that. you made this 0 down here, a 0 to the 1, and then you basically subtracted 1 from each of these, reducing both top and bottom by 1 term of 0. So what is 3 minus 1? 3 minus 1 is 2. Now what is 1 minus 1? 1 minus 1 is 0. Do you see what I see? You got to your conclusion without even realizing that you were saying 0 to the 0 equals 1. You did 0 to the 0 equals 1. That's how you got where you were. Oh wow, I was not correct when I said 0, 0 was undefined. Instead, I should have said 0 to the 0 equals 1. Going forward, I will now say that because that is what is correct. So that's probably my favorite video I've ever done. Yeah, and I'm both people, just in the sunglasses and a hat on there, which made the argument really easy to win because I knew what was happening. Where's this? Oh yeah, so this is the argument. A lot of people give this argument. That's one of the problems I have with this, where they say, oops.
0.
This thing, a lot of people who say this, like there's a reason mathematicians say that, but the problem is people who don't understand it start saying stuff like this, and because it makes sense to them, they think it's the reason, but it's not the reason. Really, what happens here is, at this step, they're creating division by 0, so they're just, it's not a, like I'm not disagreeing with people who say it's undefined, that's fine, but don't give this reason. So a lot of people who follow me, well, you'll see this a lot. A lot of people give this in my other videos I had, and then a lot of people will then do this. So it's kind of fun that they internalized it. Even a year and a half later, people are still like doing the argument from a video I did early on, which is fun. Okay, this is cool. So I don't know if you guys know imaginary numbers. I squared a -1, and if you multiply it by I continuously, it ends up looping. So eventually when you get to I to the 5th, it's equal to I. And so it creates a loop. And remember earlier I said TikTok has loops. So I kind of wanted to apply this loop to a loop on TikTok. So what a lot of people do is they'll say something like, the beginning will say the sky is blue, and at the end of the video they'll say something like, that is the reason why. So then at the end of the video, they'll be like, that's the reason why, and then they'll jump back to the beginning where it says the sky's blue, and it's supposed to create a loop where people are tricked into watching the video more, because that's one of the metrics to help the success. But the funny thing is, people don't realize you can see the jump. Like even though your words line up, you can still see the shift. So what I did was so blue on one, green, they don't match. Here, I recorded where I said, this isn't my script, but that is the reason why the sky is blue. I finished with the beginning. I put a cut right there, and I brought it to the front. So that way, there was this seamless cut, so nobody knew when it started. And actually, I can play it if we want. I want to skip to this first. Here's the comments people gave. So quick update, I've been sitting here for 3 hours and it keeps going. So since when can you upload a 3-hour long video to TikTok? Like, help, I'm trapped, when does it stop? I didn't even notice the loop, greatest loop on TikTok. Yeah, I really don't think most people realize if you just record the end and then bring it to the front, you'll never notice the loop. But I can play it for you guys if you want to see it.
Is equal to the square root of -1. If we square both sides of the equation, this square and the square root are going to cancel each other out, which gives us -1. So now we have I squared is equal to -1. This is important. Next, let's multiply both sides by I. The left-hand side becomes I cubed, and the right-hand side becomes -I. Next, let's multiply both sides by I. The left-hand side becomes I to the 4th, and -I times I is -I squared. And if you remember, I squared was -1, and -1 is +1. So we have I to the 4th is equal to 1. Well, in that case, we can just make this I to the 4th 1, and then multiply both sides by I. So I times 1 and 1 times I both are equal to I. And then by definition, I is equal to the square root of -1. If we square both sides of the equation, this square and the square root are going to cancel each other out, which gives us -1. So now we have I squared is equal to -1.
So I won't make you watch the whole thing. But yeah, so I don't know if you all saw right where the loop happened, but I did that trick where I recorded it and then just brought it to the front. Okay, so this is another one that's really popular. I think you guys probably know, at least back then, this was the most popular TikTok of all time.
The B, M to the...
Oops. I don't know why it's not playing her.
To the B, M to the B.
Okay, I can work around this.
To the B, M to the B, M, 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 M to the B. Somebody requested this. I thought it was an excellent idea. Must be extra credit from a test or something like that. I think it's a fun problem. Let's do it. I want to think of each of these M's as M to the 1. So I'm just going to put a 1 for each of those. It's still the same thing. It's still M to the B, M to the B, M, 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 M to the B. But now we've identified our exponents so we can add them together. So something like x to the 2 times x to the 3. This is equal to x to the 2 plus 3, which is x to the 5. So you can just add your exponents, and we're going to do the same thing here. So after we add the exponents, we got M to the B plus b equals m to the 1 plus 1 plus 1 plus 1 plus b. Next, we can combine all these ones to get 4. So that gives us m to the b plus b equals m to the 4 plus b. We have m to something equals m to something. The only way these two can be equal is if that something is equal on both sides. So we can say b plus b equals 4 plus b. So now to finish this up, we subtract b from both sides, and we get b equals 4. So in summary, m to the b, m to the b, m to the b means that b equals 4. You guys are awesome. I'll talk to you soon. Bye.
So I couldn't play this one for some reason, but I'm sure maybe a lot of you have already seen this one because it was so popular. Oh, on the screen? Oh, that might work. I'm sure people have seen this one, though. Oh, it's okay. It's all right.
To the B, it's M 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 to the B, bang.
So this is my peer set right here. Oh, not really. She's huge, but yeah, different. But it was cool. So a lot of people, I don't think I have any comments for this one, but yeah, it was fun and educational. Something else I thought was really cool with this one is the first time I uploaded it was in April of 2021, got 10,000 views. And then 8 months later, it got 4.2 million views. And actually, the first million views were after 13 hours. So it's kind of interesting. I don't know if it's because my account was bigger or if it's just the right time of day. Sometimes things feel random. But I thought that was kind of interesting, how much better it did. So edtech, I love edtech. This is, I won't talk too long on this, but yeah, there's videos, anything you want to watch, it's out there. Graphing, if you want to do 2D graphing, 3D graphing, data visualization, it's all free. These are all free resources anybody can use. There's notes, any kind of note you want, just type in something like unit circle. And I really like this one because right here is mine. AndyMath.com. So I'm number 2 on Google, which is kind of fun for unit circle. And then, oh, there it is, even bigger. And then for examples, oh yeah, so if you want examples, there's all these different, like I put derivative examples, calculators. So this is way different, like calculators, it's not 3 plus 3 equals 5. These are calculators that solve it for you. They literally do the work for you. And you can even get lazier. There's calculators for almost everything, like a triangle. If you plug in a side, an angle, and a side, it'll fill in the rest of the triangle for you. And then there's even stuff now where you can just take a picture, and it just solves it for you. So it's just amazing where edtech is these days and games for kids. And so, but I think most of the time it's used for grades. I think most kids are using this to get grades. I have no data to support my 99%, but I believe it's grades. And then like less than 1% are actually doing it for fun. So where I wanted to fit in the edtech world was I just wanted to be enjoyment. Like they'll learn from their teachers, they'll learn from these other resources. I just wanted people just to have fun with the videos. So that's kind of where I was going with it. Okay, this is cool. So kind of in the edtech idea, the Desmos marble slide, that's something that kids were given as homework to help them learn how to make graphs. So it looks like this. And they're supposed to have a ball drop, and it's supposed to collect all the stars. And so this is what it looks like when there's nothing in there. And then if you plug in like equations, you can then collect the stars. And so I'm sure there's millions of kids who hate this program because they had to do it for school, and it actually records your answers, and the teacher knows whether or not you did it. But I made it a game, basically. So I made all these videos on it where I just solved them, and got over 25 million views. It was pretty popular for a while there. And a lot of people wrote me on Instagram. I had people writing me in my email. I had a lot of people asking me, how do you get this app? Where is this thing? And it's just a homework assignment for kids, which is pretty funny. It's not actually a game. Well, here's one. This is how math should be taught. I'm so lucky to be at this side of TikTok. Incredible way to teach and visualize equations. And finally, interesting math. Just some comments I pulled that I liked. So here's one of them. I can play this one.
Now let's do challenge 19. If I hit launch, the marbles come from right here, and we want to hit all 4 of these stars. How do we get these marbles out of this area here? So I'm thinking if we put a ramp right here, and the marbles will shoot out here, hit that star, go through the ramp. And then we'll need to put a line right here to catch them. So that the marbles will run down this line, hit this star, and then get here. Then they would stop here. So then we need to introduce a little ramp right here that gets them to jet up and hit that. And then they'll fall down from there. So can we do this? First, I want my little ramp right here. So let's start with a circle. We'll go x squared plus y squared, and we'll say equals, I don't know, 3. So it looks about right, but I want to scoot the circle up. So I'm going to say -4 inside here. I want to move it 1 to the right. So I'm going to say -1 inside here with the x. I think what's going to happen is when the marbles come out, they're going to get caught in here and shoot out there. But first, I want to cut the circle about right there. That line looks like maybe y equals, say, negative 0.3x plus 3. Almost exactly right. How exciting. In order to cut that, I'm going to use that as my restriction. I'll copy this and put it up here. But I only want the part of the circle that's less than that. So now you can see what happened. I cut this circle everywhere below this line. And now if we hit launch, the marbles should go in there and shoot out. Perfect. So my next goal is to put a line right here that will catch all the marbles and have them hit this star. We'll say y equals x minus 1. Make it a little less steep, 0.8x. That might hit the star. Let's try it. So that hits these two other stars. So now we only have this one last star. So I just need to put a ramp right here that will then kick the marbles up to there. We'll do another circle like we did, x squared plus y squared, and we'll say equals 3 again. And I need to bring it up 1. I think that'll do it. That looks about right. So I need to cut this circle, and it looks like it'll be perfect if I cut it at y less than 0. So squiggle marks, y is less than or equal to 0. That looks about right. So now the marble should come down here, hit this ramp, go up here, hit that star, and then hit that star and fall down. So let's see how they do. Here they go. We got it. How exciting.
Yeah, so that was it. And this is the first time I ever said how exciting. I don't know if anybody follows me, but I'm required to say how exciting in all my videos now at the end. If I don't, I have so many comments saying you forgot how exciting. I just casually said it in this one, and then it just became a thing. So many people copied this. So many people. I had people in different countries, Spain, I think South and South America. I had a lot of other people. And they did almost the same thing I did, but this guy was my favorite. Oh shoot. Well, this guy's my favorite. There it is. This guy's my favorite. I wanted to share this one because he did it all with one equation. So I thought that was pretty ambitious. He took the same approach I did. Everybody took the same approach I did, which maybe that's the most reasonable approach. But, what's that? He did the cosine. Yeah, I guess he took the same path of the balls. Oh, wait. I never looked at it, really. But yeah, it's pretty cool what he did. And then, so his name's Desmos. He created his account. He says, based on me, he actually sent me a note and told me. And he made this as a thank you. So this is andymath.com as an equation. So it's kind of fun. But yeah, he says I inspired him, which is kind of a fun thing to do. There it is again. So area equals pi r squared. I kind of like this one. I think everybody knows this from a very young age, that the area of a circle is pi r squared. And with calculus, there's cool ways you can do it, but there's geometric things too. So I made these videos, but I'm not going to play them, but I'll just show you what they're about. Like you can take a circle, you can cut it either into pizza slices or pie slices, or you can cut them into concentric circles. And then if you break them up, they form either a rectangle or parallelogram or a triangle. And so then you get the base times the height, or 1/2 base times height, and that's what gives you an area of a circle. So this isn't really proof, but I just thought it was a fun demonstration. But these are pretty popular videos too. A lot of people saying, oh my gosh, I never knew why, I just always believed it. Kind of makes it fun. So a squared plus b squared equals c squared for a right triangle. Lots of demonstrations of this online, but one I hadn't really ever seen was this one. So I just made this for people, and I'll play this one.
This person requested Pythagorean theorem. So we start with the square, then we have another square that's the exact same size. So these two squares are equal to each other. Then I'll make a cut that is the same size as A, and I'll do the same thing to the other square. Do the same thing to every side of that square, and the same thing to every side of this square. And then this other piece will be B. Then if I make a cut right here on both squares and pull this triangle out, this is the same triangle that's in our notes up above. So this side right here is C, this side is also C. And let's bring these down here. Next, let's make another cut here where this is A and this is B. And let's make a cut here where this is C. And then if we pull both of these triangles out and bring them down there, these two sides should still be equal to each other because we pulled the two same triangles out of both of them. Now let's make some more cuts. Here, here, and here, and also here and here. We've now made more of these ABC triangles, and we can pull them out and bring them down here. And so out of both sides, we've pulled 4 of these ABC triangles. So they should both still be equal. So this square right here is an A by A square. So the area of it is A squared. This square has sides B, so its area is B squared. And this square has sides C, so its area is C squared. We can call this left-hand side A squared plus B squared because we're adding these two squares together. And that's going to be equal to this right-hand side, which is C squared. And that's the end of this demonstration. Trust Fuller, I hope this helped. Thank you for the request. You are awesome. Let me know if you have any other.
Sorry. Yeah, so I thought that was a neat one. Kind of that aha moment. A lot of people comment on the aha moment at the end where you saw the a squared is b squared equals c squared. It's kind of fun. History, math, go through this. So practical purposes, just business, travel, time, construction. And then you had enjoyment, which I think a lot of geometry and calculus came from just enjoyment. So like Euclid, he wrote his 13 books on geometry. I don't think he needed that for food. I don't think he needed that to survive. So it was kind of this enjoyment element behind it that led us to all of that. And same thing for calculus. They wanted to know, what is the slope of this line? And they couldn't do rise over run because there's no rise or run when it's a single point. So then they figured out how to do it using limits. And no one needed this when they did it. It was more enjoyment. And I actually don't have evidence of that, but that's what I believe. We use it now, but I don't think they needed it back then. So that's kind of why I try to bring in an enjoyment element into edtech, because I think that plays a really important part of the growth of math and everything. Monty Hall problem, I'm sure a lot of people know this. I'm not going to play the video, but I can try talking about it really quick. So if you have 3 doors, you can have a sports car and a goat, and two goats, I guess, and then you choose a door trying to find the sports car. And so if you choose this door, and then I show you a door, that one of the doors that has a goat behind it, keep in mind, I'm not going to show you the one that has a sports car, because then you'll just choose it. So I'm showing you specifically one with a goat. What is your, do you keep your door or change it? So, yeah, I think most people probably know it. Is it 50-50? Well, it's not. It's 1/3, 2/3. And so from here, I create a visualization going over it. I don't know how many people in the room know it or not. But like, here's the 3 scenarios. It could be on the door you chose or one of the other 2 doors. So then in this scenario, I'll just show you the goat there. And then for the top one, it doesn't really matter. I'll show you a goat. So the red door represents the keep, and the blue door represents the change. So if you look at it, if you keep it, you have a 1 in 3 chance of having a sports car. And then if you change, you have a 2/3 chance of getting the sports car. I went through this kind of fast, so if anybody doesn't understand it, just look up Monty Hall. There's so many videos on it. But I thought it was a fun thing to talk about. And then, something for everyone. So this is something I think is really important. A lot of people making videos, they'll do like a calculus video, and it's basically only for calculus students. Or you'll have someone doing lower end stuff and it's basically for younger kids. I try to literally in all my videos have something that everybody can benefit from. So if it is something really complicated like calculus, I try to go super easy with stuff so that at least if they don't understand the whole thing, they can get something out of it. And then if it's something really simple, I try to do something you've never seen before, something with a little twist to make things interesting. So I always surprise when I watch his videos. This is good. I've never been this entertained by math ever, so that's kind of fun. Okay, yeah, so higher end concepts explained. So there are so many easier ways to calculate this. Yeah, so one guy wrote, there's so many easier ways to calculate this. Well, that's exactly what I'm talking about. I know there's easier ways, but I'm trying to include younger people into this. One guy wrote, definition of show your work. I was literally showing every single step. It must have been really annoying to him. If only everything was explained this well. Yeah, and then on the other side, if only everything was explained this well, kids would be geniuses. And I actually understood that, so there's some kid who could actually understand it because I was willing to explain it really simply. And then for the lower end stuff, this is a math teacher, and he has an account as well. And he says, this may be the best proof I've seen. So it's a pretty simple proof, but he's never seen it before because I made it up. So it's just kind of fun to show him something new and him be like, oh, this is cool. And then the people who wrote this one clicked, and that was a twist ending I should have seen coming. It truly was exciting. So I try to do that with every single one of my videos. I don't like to focus on just one audience. So gambling probability. I made a whole bunch of videos on gambling. The 2 highlights was everybody's done the whole, if I double it every time I lose, I can't lose because I'll win all my money back. So I just created a scenario in one of my videos where the minimum bet was $10 and the table limit was $10,000. And this is what the math came out to. This is for roulette. It came out to that you have a 99.84% chance of winning, which is amazing. You're going to win always. But you are only going to win $10 for each of those rounds. But if you lose, you have a teeny tiny chance of losing, but it's $10,000 you're going to lose, $10,230. So your expected value ends up being you lose $6.38 for every $100, even with the doubling routine. So it's kind of a fun video. And then, this comparing European versus American roulette. So then you have, with European, it's just the 1 0, whereas American, you have the 2 zeros. So for European roulette, you're expected to lose $2.70 for each round. With American, you're expected to lose $5.26 cents per round. So a lot of people in the comments are like, oh, Americans are greedy, Europeans are better than Americans. But then they don't realize how greedy we actually were. We now have triple zeros in America. So it raises the house edge to $7.69 for the triple zero. So I thought that was kind of a fun video. Negative times negative is a positive. So this is one of the things that everybody just memorizes, like negative 6 times negative 6 is positive 36. And here's a proof. Sure, you can look at that. But this is a video I made where I kind of told a story to help people kind of understand it. So I'll play this.
Why is a negative times a negative equal to a positive? I get this question so much. I think it's best with an example. So if we have a mountain and let's say it rains on that mountain and it erodes every single year, let's say that it erodes at a rate of 3 millimeters per year. So we would say negative 3 millimeters per year. So then if somebody asked me the question, how much shorter is it after 8 years? We would take the negative 3 millimeters per year, multiply it by 8 years, and we get negative 24 millimeters. So this negative means that it's 24 millimeters shorter than it was. Now someone else might ask, how much taller was it 5 years ago? The same thing, we would take our 3 millimeters per year. This time our 5 will be negative because we're going backwards in time. So it's negative 3 times negative 5. And that gives us positive 15 millimeters. And it's positive because it's taller. And that makes sense because if it's eroding down 5 years ago, it would have been taller. So this positive makes sense. How exciting.
Yeah, so that's that. And yeah, I have to say that now at every one of them. So yeah, by far the best intuitionist I've seen. Well done. I'm memorizing this for the future. For 30 years, this has eluded me. So it's kind of fun that there's people who, like, they memorized it, but they didn't really understand, and this kind of makes it click for them. Do you mind if I share this with my students? And I have a whole generation of people that are now going to do it my way. And then 43 years, this guy's a little bit older, and he's finally understands it. So yeah, stories help make it more enjoyable. Oh yeah, this is kind of fun real quick. So yeah, here's my YouTube. TikTok, 5.3 million views. On my YouTube, 18 views. Exact same video, exact same time I uploaded them, but I just don't click on YouTube for some reason. Here's a whole bunch of other ones that do a lot better. And I think on TikTok, engaging content's rewarded. So somehow I'm able to hook people right at the beginning. Whereas on YouTube, you got to play them. So it's almost like engaging content just might never be seen. So I kind of take it as a compliment. The people who do see me want to see more. Whereas on YouTube, they just don't even know to find me. Okay, this might have to be the last thing. So I made a rock, paper, scissors tournament. And I literally just told people, hey, in the comments, can you put S's, P's, and R's? I thought maybe I'd get like 64 people to do it or something. I ended up getting 35,000 entries. I had trouble pulling all the entries, but here's a whole bunch of them. But yeah, the whole comment section, I think this, I should look into it. It might be one of the most commented videos. I think maybe 10% of people who watched it commented on this, where it's usually like a fraction of a percent. It's kind of funny. But yeah, all these people entered, and yeah, I had to write a whole program to choose a winner for it. That was kind of fun. It might be, should I keep going? Okay, I'll just keep going. So then, Fibonacci sequence, we have this right here. I think you guys know it. You just add up the previous numbers. And if you look at the ratio, it gives you like around 1.61. Ends up being the golden ratio. It approaches the golden ratio that's so famous. And it's funny because from mile to kilometer, it's very close to that. It's 1 to 1.609. So I just made a video. I didn't explain this the same way, though. I just made a video where I converted miles to kilometers using the Fibonacci sequence. And yeah, we can use that. So I can play that video, too, real quick. This is an old one, so it's kind of embarrassing for me to watch.
No, you can use Fibonacci to convert from miles to kilometers. I did not know this. Let's check this out. This is the Fibonacci sequence. You get it by starting with a 0 and 1, and then the next one you get by adding the previous 2. So 0 plus 1 is 1. 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5, and so on. Well, let's Google miles to kilometers conversion. So I'm going to plug 3 into the miles, and it gives me 4.82. That rounds to 5. That's interesting. Let's try plugging in 5 to the miles. And that's even closer to 8. And there's an 8 right there. This is fun. Let's plug 8 into the miles. We get 12.87, which does round to 13. Okay, what happens if we plug 13 in for the miles? It's 20.92, and that does round to 21. I'm gonna see if this keeps working. I'll plug in 21, and that's 33.79, which does round to 34. Let's plug in 34, and that's 54.717, which does go to 55. So I'm guessing this goes on forever. This is pretty cool. I don't know what we would do with that, because we would literally need to know exactly 34 miles. This trick won't work for 32 miles or 25 miles, something like that. And even then, it's a little off. But I think this is a fun one. Thanks for sharing it with me. Keep sending me more of these fun math facts. You guys are awesome. I'll talk to you soon. Bye.
Yeah, so this is something that someone had commented and told me to do, so then I made it. Yeah, so I have so many more I want to share with you guys, but I ran out of time. I can play a limerick real quick. That was fun. Right here. It's a pretty short one.
A dozen, a gross, and a score, plus 3 times the square root of 4, divided by 7, plus 5 times 11, is 9 squared and not a bit more.
And that was it. I got like 400,000 views on this. It took me probably 2 minutes. From the moment I saw it online, it's like, oh, I should do this. I recorded it and then uploaded it. So it's kind of fun. Yeah, I think that's time. We don't have time, so we have to do this. I actually timed it really well, didn't I? Because it ended right there. Yeah.
Okay, great. Thank you, Annie, for this really fun talk. I hope you all enjoyed it as much as I did. I guess we have some time for questions now. If there's anybody in the room who wants to ask something. Yeah.
Hi, thanks for the talk. Do you think math should be taught like this? Do you think math should be taught like this?
Should be taught like this?
Yeah, like in a comment.
I think that I'm lucky there's teachers out there, so I don't have to actually do the teaching. So I think it just plays an important part in it, in having fun. But no, I would not want someone to learn just from me, at least not me doing it this way. But I do think that kids can get or less scared going to class, knowing that there's this TikToker. It's like, oh, this can be fun. I'm not sure exactly, but I know I would not teach exactly this way. What do you think?
I think it's a good addition. Like you can use it in class, but probably you need the boring stuff a little bit as well, probably.
Yeah, my stuff is not. I always say demonstration at the end because none of these are proofs. And if I ever don't say this is just demonstration, I get so many comments. People are like, oh, that's not a valid proof. Oh, you missed this, you missed this. So I always try to cover my bases because it's not the dry, thorough stuff. Yeah.
Yeah, what was first, your name or your interest or your fascination for math?
I kind of always liked math, but yeah, it's not my real name, so it's based on that. It was based on Craigslist. It was Craigslist, so I was like andymath.com when I made the website, and then I made the TikTok later, and I kept the name. But yeah, I've always liked math as a kid. I have 2 college degrees too in math, so I've always kind of enjoyed it. Yeah.
Yeah, so maybe speaking of that, in college, at least my experience was the great thing about math is that the rules are really clear. Like it's always clear what you can do. And at least for this controversial thing, I think the reason why these 0.999, et cetera, are controversial is that the rules aren't really clear. And I mean, in your video, okay, you don't really explain what the rules are, which is fine for this content, I guess. But for me, this is like the thing that makes math fun, that it's always clear what to do. And I think this is really what for other people is a problem, that you learn all these techniques which you have to know for your grades, and nobody tells you why or what you're allowed to do. So is that something that how do you deal with that, like introducing this aspect of math to people who think of it as, oh, here's all these algorithms, I have to remember the right one, and then have to apply it perfectly?
Ooh, I don't understand. Sorry.
I guess it's a disconnect between university math and high school math, where in high school math you... Okay.
Sorry, I don't want to give you a nod. Let's talk right after. I can figure out. Yeah. Cool.
Maybe a question about the difference between. You showed this huge difference between viewer numbers. Do you really know why this is? I mean, do you rely on some algorithms suggesting your videos, or on TikTok do you rely on people already knowing your name and looking up your videos specifically?
Sure. TikTok is definitely just in people's feed, so I don't think anybody's looking me up. Whereas in YouTube, I think probably accounts that are already large are showing up in people's suggested, right at the top. But I think for a lot of YouTube, you kind of have to search for what you're looking for. And I think my account's just small. I think it's just my account's probably small. compared to YouTube. And then I just got lucky that since in TikTok you just show up, then I'm able to catch people in those first couple seconds, and then my account can get bigger. But yeah, that's the best guess I have. I wish my YouTube was bigger, but yeah, it's not.
Anybody else has a question? Yeah.
With this difference, do you ever try to game the system or analyze what time is best to publish or something to optimize your views?
Tried. I did try for a while, but it got so stressful because there's just nothing. The one thing I have noticed, though, this is good. The one thing I've noticed is if I mention my website, if I mention anything that is external, it gets suppressed massively. So I think TikTok like reads your text, like your subtitles, and they read through your screen. And if they see a website, if they see anything, I'll usually cap out like 2,000 views. Whereas if this exact same video where I don't say something would probably get like 100,000 views. So it's just kind of an interesting phenomenon. So that's something I have noticed for sure. And I think they're trying to prevent people from leaving the platform, and they obviously have the technology to do that, so they do it. But in terms of time of day, I feel like I had it under control, and then no, I'm just so surprised. Like the one that was 10,000, that was, I would have thought prime time day, the M to the B one. But then the 4 million one, I think I did that at like 7 p.m. at night, which usually isn't my best time. So it seems random, which I think a lot of other TikTokers say the same thing about that.
Any more questions here in this room? No? If not, I will take the opportunity to thank you again, Andy, for the really fun and interesting talk. And I am thankful that you were all here, and wish us all a very pleasant rest of the day and of the Big Tech Day. Have a fun day.
Thank you.